We often hear that the universe is governed by four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But this is only part of the story. Overview of fundamental forces. The four fundamental forces commonly discussed are gravity, governs celestial movements and keeps us grounded. Electromagnetism unites electricity and magnetism and explains light and chemical interactions. Strong nuclear force holds protons and neutrons together in the atomic nucleus. Weak nuclear force responsible for some radioactive decay. Different behaviors of forces with distance. Force strength varies with distance. Electromagnetism and gravity weaken with the square of the distance, known as the inverse square law. Gravity's relative weakness. Its impact varies depending on the charge-to-mass ratio of particles. For example, gravity between two protons is less weak than between two electrons. The strong nuclear force exerts minimal force at extremely short distances. Peaks at the size of a proton, which is about 1 femtometer. As distance increases, energy builds until new particles are created, neutralizing the force. Behavior of the weak nuclear force. Weak force carrier particles. These particles are massive, about 100 times the mass of a proton. Their large mass makes weak force interactions rare, as they can only exist briefly due to the Heisenberg uncertainty principle. Range. The weak force is active only at distances less than 1/1000th the size of a proton. Comparing forces under varying conditions. Energy determines strength. The weak force becomes relatively strong when acting on top quarks, which are the heaviest known subatomic particles. Top quark decay occurs faster, in about 5 × 10⁻25 seconds, than the strong force can act. The weak force dominates because the top quark's large mass removes the usual energy barrier. Misconceptions in popular science. The hierarchy of forces is often oversimplified. Popular science describes forces at specific conditions, but understanding requires knowing how forces behave under various distances and energies. For example, while gravity appears weak at atomic scales, it plays a dominant role in everyday life. Physics in a broader context. There are limitations of simplified models. To fully understand forces, one must explore how they behave under changing conditions and contexts. The top quark and weak force show how what seems weak under typical conditions can be strong under others. Conclusion: ongoing exploration in physics. Understanding forces requires deep dives. Popular science only scratches the surface of how fundamental forces behave.